Okay, so chapter 8 was over covalent bonding, and this was another big chapter to grasp, and I'll just show you what we kind of went through and learned in this section. So in section 1, it was over the molecular compounds, and this was kind of just getting us used to and telling us what molecular compounds were. And a molecular compound is a compound that is a neutral group of atoms that generally contain at least two atoms that are combined by a very strong covalent bond. And we learned about covalent bonds and what they do. And it showed a little thing over noble gases like helium and neon, which are non-atomic. This means they exist as single atoms, and helium is less dense than air, which is used to inflate balloons, and that is why balloons float in the air. Molecular compounds have lower melting and boiling points than ionic compounds. These are just some general facts. And a molecular formula shows how many atoms of each element a molecule contains. So that was kind of what we went over, and we did some labs that had to do with molecular compounds. In section 2, we learned the nature of covalent bonding, and learning that oxygen atoms can join in pairs to form the oxygen you breathe, and you can also join in groups of 3 oxygen atoms to form ozone high in the atmosphere. And it explains the octet rule in this section, which we had to work with on a piece of paper. And single covalent bonds are 2 atoms held together by sharing a pair of electrons that are joined. And hydrogen gas share only 1 pair of electrons, which form this. And double and triple covalent bonds are more. They are atoms bonded by sharing more than 1 pair of electrons. And atoms form double or triple covalent bonds if they can attain a noble gas structure by sharing 2 or 3 pairs of electrons. So we learned the single and double and triple covalent bonds. And then a coordinate covalent bond is which one atom contributes both bonding electrons. So that was more over bonding in that section. And then in section 3, we go to the bonding theories, and it described the VSEPR theory, and the repulsion between electron pairs causes molecular shapes to adjust so that the valence electron pairs stay far apart. So it'll kind of work out on its own, so it will all turn out in the end. And then this is just something to think about. Consider a car being painted, and the process is called electrostatic spray painting. A custom designed spray nozzle wired to an electric power supply makes negatively charged to the paint droplets as they exit the spray gun. The negatively charged droplets are attracted to the auto body. Painting with attractive force is efficient because all the paint is applied to the car body and very little is wasted. With this, we learn how attractive and repulsive forces influence the shapes of molecules. So we learn how molecules are formed and their shape and how they are attracted, and they are used to do this to create these molecules. And then in section 4, we go to polar bonds in molecules, which was also a big section. We learned about bond polarity, polar covalent bonds, polar molecules, and hydrogen bonds. And something important is the more electronegative atom attracts electrons more strongly, it gains a slightly negative charge, and then for the opposite, the less electronegative atom has a slightly positive charge it will end up with. So these are just some things to keep in mind when thinking about polar bonds. And non-polar covalent bond is when the bonds pull equally, then the bonding electrons are shared equally. And polar covalent bonds is covalent bond between atoms in which electrons are shared unequally. And this section was pretty much covering all the same topic, just broke it down step by step, showing us how to do it correctly and making sure that we understand how to bond molecules.